This is the intro to Module 9, assessing studies based on multiple regression. So now we're going to put it all together. This is wrapping everything up. Once we've done a bunch of analyses, or somebody else has done some bunch of analyses, how do we evaluate them? So the main question we're asking here is, when does multiple regression provide a useful estimate of a causal effect? We've always been doing the student-teacher ratio example with respect to test scores. We've always been interested primarily in the student-teacher ratio coefficient. And the question is, when is it that estimate, when can we consider it a causal relationship? When does it fail to do so? In other words, when is it just correlation? And this module is about creating a framework for assessing statistical studies in this light. Oops. Two things to consider: internal and external validity. Okay, the definition. Population studied is the population of individuals, companies, etc., from which the data sample was drawn. This is in contrast to the population of interest. So far we've only really talked about the population in general. Now we're saying there's a difference between the population studied and the population of interest. And this is the population of interest is the population we wish to draw inferences about. We wish to draw conclusions about. For example, we have studied the effect of elementary school class size on test scores. Can we generalize our findings to high schools as well? That would be external validity. The population of interest there would be to high schools, and the population studied would be elementary schools. Can we generalize the effects we see in the laboratory to the field, i.e. real humans or real agriculture? The population studied would be the laboratory participants, and the population of interest would be real humans. Internal validity. We'll define this: if the statistical inference about the causal effects are valid for the population being studied. So we have a population that we are studying, we've drawn samples from, we estimate regressions on that population, or the sample is drawn from that population. Are the results that we gather from our regressions, are those valid for that population being studied? Do the results make sense for participants in the laboratory, for example? Do the results make sense for elementary school students if our population studies is elementary school students? We're going to look for two conditions. One, the OLS estimator, the effect we are interested in, should be unbiased. Okay, so that's going to be that all OLS assumptions are valid, they're not violated. And the hypothesis test should have the desired significance level, and confidence interval should have the desired confidence level. In other words, we want to reject null hypotheses with a desired significance level, usually 5%. External validity, in contrast, if the inferences and conclusions can be generalized from the population and setting being studied to other populations and settings. Can we believably extrapolate our findings to other settings? Let's evaluate external validity first in terms of the student-teacher ratio and test score example. The causal effect might be different between the population studied and the population of interest. So the population studied was elementary schools in California in 2005. That's what the book has data on. Can we extrapolate those results? Would those results also apply in Massachusetts in 2005, to elementary schools in Massachusetts in 2005? Maybe. Massachusetts isn't so different from California in terms of elementary schooling, so maybe they would apply. Can we extrapolate to elementary schools in Mexico in 2005? That's maybe a little harder to argue that Mexican elementary schools are the same as Californian elementary schools. There might be some significant differences there that we need to account for if we're going to estimate that relationship in Mexico. How about elementary schools in Germany in 1946? Probably not. That's the height of World War II, so there's other things going on. So basically what we're saying here is that the effect of student-teacher ratios on test scores is probably different in Germany in 1946 than it is in California in 2005. So this is External validity, we said that maybe the results in California are externally valid for Massachusetts, but probably not for Mexico and Germany. Some threats to external validity. The population studied was chosen in a way that makes the characteristics of the people in the study unique. We could choose to study the effect of a drug on people that show up at a hospital. Those people that show up are more likely to be sick in the first place, so they're different from the entire population. So if we study only people that show up to a hospital, like if you have COVID patients showing up to the hospital and you determine you give each of those patients a particular drug, they're not really representative of the population because you're getting only the people that are actually affected by COVID. An extreme example, we might have a lab experiment that we run on mice. Are those results applicable to humans? Can we extrapolate those results to humans? We don't know. Mice and humans are different. We also know that student test scores and class sizes cannot be in elementary schools cannot be extrapolated to college students. And so this is basically the question of how far can we take these results? How far can we extrapolate? And so there's no real test for this. We just have to argue it. We also have differences in settings. Even if the populations might otherwise be the same, the setting could be different. These are called exogenous differences. So we might have differences in the effect of information for people in Colorado versus Wyoming. The two states have different existing regulations. The effect of information on anything really. We also have different ideologies within Colorado and Wyoming, and so giving people information in the two different states might have different effects. The same information. Another example is anti-drinking advertisement impacts on college student. Binge drinking could differ by college depending on the existing drinking penalties in place. So if you have college students are essentially the same across colleges, we're going to assume that. And we're giving anti-drinking advertisements to two different colleges. Those advertisements might have a different effect depending on the severity of the punishment for drinking at each of the colleges. So how to assess external validity? I already kind of mentioned this, there's no statistical test for this. It's based on argument and knowledge of the setting and the populations. You can, however, do a test in two separate states and then compare results if states are your unit of analysis. And if you have data from the two different states, are the results similar in magnitude? If not, why not? What other factors might result in the difference? You have to come up with an argument depending on your setting. There's never one solution to all of these. Okay, next we're going to look at internal validity.